video, I would be solving the problem for centroid of unequal eye section. Let us read the question. Find the centroid for unequal eye section having following details. Top flange is 20 mm into 10 mm. Bottom flange 100 mm into 20 mm. Web thickness 15 mm and overall depth 250 mm. Now whatever is given here, I will first draw the diagram for unequal eye section. So let us start the solution by drawing the diagram. Now this is an unequal eye section. Here top flange is 20 mm into 10 mm that I have already drawn. I'll write the dimensions here. Top flange is 20 mm. So here this width is 20. And the height is 10. Bottom flange is 100 into 200. 100 into 20. Actually it is 20, not 200. So it is 100 into 20. Web thickness is 15. And overall depth is 250. Since overall depth is 250, the height of web we can calculate. So it is 250 minus 20 plus 10, that is 30. So 250 minus 30 will give me 220. So that is the height of web. It is 220. And here whatever dimensions I have written, so all dimensions are in mm. Now here in this question, they are telling us to find the centroid for unequal eye section. So if we have to find centroid, it means we have to calculate x bar and y bar. So this is the question in front of us. Now let us try to get the solution for this problem. Since we don't have any direct formula to get the centroid for eye section, here I will divide this eye section into three simple rectangles. Now this will be my rectangle number 1, rectangle 2 and rectangle 3. First I'll take rectangle number 1 and get its area. I'll say that since area 1, that is area of first rectangle, it will be 100 into 20. So that is 2000 mm square. Then x1, it will be equal to, x1 is the location of y-axis for first rectangle. So for the first rectangle, y-axis will be exactly at half of 100. So x1 is 100 divided by 2, because it would be at half of 100. Next y1, y1 is the location of x-axis for the first rectangle, and for the first rectangle its x-axis will be at half of 20. So that is y1. Similarly, I will calculate for second and third rectangles. I'll say that since area 2 is equal to 15 into 220, so area 2 value, it comes out to be 3300 mm square. X2 is equal to, for the second rectangle, again its y-axis will also be at half of 100 because they are passing, or in other words if I can say, the distance of x for all three rectangles, they would be same, because from the origin the y-axis of each of the rectangle is at same distance. So here x2 will also be half of 100, that is 50 mm. Y2 will be 20 plus half of 220, 20 plus half of 220. Why I am taking half of 220? Because its x-axis will be exactly at half of 220, and I am adding 20 because I am measuring the distances with respect to origin. So therefore y2 value comes out to be 130 mm. Similarly, I will calculate area 3, that is equal to 20 into 10 x3 value will be equal to, again the location of y-axis which I have shown in blue color, it is same for all three rectangles and the distance is half of 100 with respect to origin. Y3 will be equal to, now the x-axis for third rectangle, since it is starting after 20 plus 220, that is after 240 mm, the third rectangle is starting. So I'll write down y3 is equal to 240 plus the x-axis for the third rectangle, it will be at half of 10. So it is 10 by 2. So this comes out to be 245 mm. Now after getting all the values of area, x and y, now I will locate the centroid. That is, first I will go on to find x bar. So since location of centroid, with respect to y-axis, that is x bar will be equal to a1x1 plus a2x2 plus a3x3, since we have three different areas, upon area 1 plus area 2 plus area 3. This is the formula of x bar. So I'll put all values here. So that becomes area 1, it was 2000 into x1 50 plus area 2, that was 3300 into x2 50 plus area 3, that is 200 into x3, that is 50, divided by area 1 plus area 2 plus area 3. So from this I will be getting the value of x bar. So therefore x bar comes out to be 50 mm, and this is my first answer. After this I will find y bar and location of centroid with respect to x-axis. Y bar will be equal to a1 y1 plus a2 y2 plus a3 y3 upon area 1 plus area 2 plus area 3. So now I'll put the values here. A1 is 2000, y1 it was 10 mm plus area 2 3300 into y2 130 plus area 3 200 y3 245 divided by area 1 plus area 2 plus area 3. So from this I will get the value of y bar, and my answer is 90.55 mm. This is my second answer. Now once x bar and y bar have been calculated, we can easily locate the centroid. I'll draw the eye section again and locate the centroid over that. So here is an unequal angle section which is given in the problem, and the dimensions of that angle section we can mark it. Now, for this unequal eye section, the centroid is located by x bar and y bar values. X bar was 50. So exactly half of this. Here we have x bar is equal to 50 mm and y bar is 90.55 mm. So after getting x bar and y bar, we have located the y axis and x axis for this eye section. Their intersection will give us the centroid. So here we have the centroid, and as we have located the centroid, we complete the question.